So today we are going to be talking about how computers actually work for AI engineers. My name is Ray Oshafi. So you see, there are actually four components of a CPU, and these include the operating system, the RAM, the processing unit, and the storage. When we are talking about the storage, we have the hard disk and the SSD, which is permanent. Okay, then we have the RAM, which is active when the system is at work and is actually fast. So in regards to artificial intelligence, if your AI model is larger than available RAM, it cannot be processed. The system will either crash or slow to a crawl. So memory management is actually a core AI engineering skill. All right, so let's talk about the vertical descent from software to hardware. The file here, train.py, is actually the Python file. So if you run this on your system, is actually to go through the Python interpreter, which interprets the code, okay, to the operating system. Okay, then it flows through the different cores of the CPU to the RAM or the SSD or HDD, as the case may be. At the binary level, it can either be 1 or 0, of which 1 means it is charged and 0 means it is uncharged. Do you understand? So that is what binary is, which is just combinations of zeros and ones. All right, 1 means is charged, while 0 means it's not charged. Then this is about quantization. Okay, so we have the int, the float, of which the int can be int 4 or int 8. Then we have the float 16 of float 32. So the main thing is that every weight in a neural network is a floating point number. Okay, you just have to understand this, and reducing precision mathematically will shrink the hardware required to run it. Okay, so we'll see more of this calculation later. All right, so for instance, you have a 7 billion parameter of a model that you want to run. You have to multiply it by 4 bytes, okay, which will give you 280 gigabyte requirement of RAM for you to be able to run that model. If we should talk about the scale of AI data, you can see that it moves from bits to kilobyte to gigabyte to terabyte and to petabyte. Estimated size of GPT-4's training data is 45 terabytes. Okay, so this is what the information here is trying to relay. Okay, let's move forward to the execution cycle. So the execution cycle of a typical system is in 4 areas, which include fetch, decode, execute, and store. So for fetch, the system reads the next instruction from the RAM and it translates it into electrical signals, which is then executed in terms of math or logic functions or operations. All right, then stored in the storage of the system or the memory of the system. When we are making a comparison between the CPU and the GPU, which is the central processing unit, versus the graphic processing unit, because actually it is graphic processing unit that we use in training large language models, okay, not CPUs but GPUs. Although the CPU is very fast and the GPU is a bit slower, the truth is that when you combine what the individual cores of a GPU can perform, okay, or can compute, it gives a better result for AI engineering or training of models. That is why GPU is usually used for training AI models. Why you can liken CPU to 8 intelligent professors, the GPU could be likened to 10,000 students. Okay, so if you give them a matrix multiplication in neural networks, you will see that the students are going to outperform these other guys by a factor of thousands. So this is just actually an illustration. If we should further look at the architecture, Okay, in terms of core count, optimal workload, and AI rule, you can see the CPU in this regard, which could be between 4 and 128 powerful cores. Okay, that is for the core count of the CPU, while the GPU could be thousands of smaller cores. All right, so for optimal load, it could be in form of a sequential logic or branching code, while this could be very massive, right? Then for AI rule, the CPU can just run the code, all right, or orchestrate data pipelines, while the GPU is the native environment for deep learning training. Always audit your hardware before writing a single line of model code. You have to connect physical specs directly to mathematical constraints. If not, your system will either crash or run to a crawl. For AI engineering, you have to understand things like memory limits, things like binary precision, things like execution architecture, because AI engineering is ultimately a hardware optimization problem. Okay, this is very important. So mastery over machine is what we are talking about, or what this course is all about. You have to understand the configuration of your machine so that you'll be able to process your models and get the required outcome. All right, so this is the end of the course. This is just a simple course, and we shall be getting back to you later. Thank you.